Still no ding. Usually I used to get a ding in the headphones that told me when this began. Alright. It's Professor Nelson, Fashion Institute of Technology Jewelry Design Program, doing a tutorial on stone layout in Rhino, Pave. Alright, first thing that you have to have is a stone before you do anything else. So I will import from my library a stone. Unfortunately, I have it held in more than one place, so right there. This is the 10mm stone that those of you at FIT should already own. My library stone has a couple of extra features, yours might not. I have a curve around the girdle, and I have a point in the middle of the stone, which helps me with orientating my stone. Orientating would be a non-word. Okay, so grouped together so I can have control of them. I'm going to lay this stone out at, I'm going to lay it out at 1.3mm. So to get a 10mm stone down to 1.3mm, I'm going to do a universal scale around 0.13. Because I'm extra thorough, I'm going to double check that this is indeed what I expect it to be. Analyze diameter 1.3. Good. Alright, I need to make a cutter. So actually, I will take this and I will create a conical cutter to create seats for this piece. Easiest way to do that is going to be extrude to point. Pick another layer color. I like my cutters in orange. I'm going to bring it down to the end of the stone. Now what you're going to find once I've done that is that it's invisible. Okay? It is trapped inside of the stone. If I turn the stone off, you can see it. It's right there. I can make this a little bigger. I can play with it. The reason, of course, that this is hidden is that the stone bulges outward, where the lower girdle facets and the mains run into each other. Hang on 1 second, please. Okay, sorry about that. So, having extruded to the point, if I want it to so I can see it, just for my own personal comfort, as it were, I can select that, and I can do a non-uniform scale. Once again, origin point. Remember, whenever you scale in Rhino, Rhino is asking for three things. It wants an origin, it wants how big is it now, and how big do you want it to be. That's what Rhino always wants. Wants 3 clicks. Where is it going to scale around? How big is it now? How big do you want it to be? Origin point is where do you want it to start from? I'm going to hit 0. Okay? This is non-uniform scale, so I get to scale in 3 directions. I only want to scale in 1. So if I don't want to change the scale, I just hit 1 or hit enter if one's already in the window. I'm going to tell you right now the best practice is to forget what's in the command line right here and just always assume if you don't want it to change, hit 1, enter. I don't want it to change in this direction. 1, enter. This is the direction I want to change in. Now Rhino's waiting for its 2 extra clicks. How big is it now? How big do I want it to be? Okay? I can click anywhere. It doesn't matter where you click for the "this is how big it is now" click. Rhino just wants a reference. So anywhere you click, Rhino memorizes and says, oh, that's how big it is now. And once you click that, you'll see your object highlight. The second click tells Rhino how big you want it to be. I'm going to pull down on this cone until it's pretty much clear of the pavilion of my stone. And then I'll give it that third click, which tells me how big I want it to be. And there you go. Okay? This creates the seat for our stone. Now, I have to tell you that what we just went through is somewhat unnecessary. You could have left it exactly as it was. In casting and then finishing, when you put in this stone for actual setting purposes, this cup that you're creating is going to get ground away, polished away, worked away anyway. It's a rough guide for the setter. So to go through the extra trouble that I just went through to make this cone a little bit bigger so it looks more like it's big enough to hold the stone, that was for my own warm fuzzies only. In real life, at the scale we're talking, it would make no difference. Okay? But it's good for you to see how it's done. I want to put a line on this cutter, which will end the seat. This cutter is going to be the seat the stone sits in. So I'm going to extract an isocurve. That's the wrong direction. Okay. So if I wanted to change direction, I can hit T. That'll toggle to the other direction. I want this to come about 1/3 of the way down the pavilion of my stone. So something like that. Once again, this is not a hard and fast thing. What you do want to make sure of is that the diameter of this circle, once you're done with it, is somewhere close to 1 millimeter, not under 1/2 millimeter. Because if you have something that's under 1/2 millimeter, in the finished piece, this will create a hole. And if a hole is under 1/2 millimeter, it's a casting and cleaning nightmare. So you're going to check in the diameter of that. And mine's at 0.881. That's perfect. That's fine. Okay. I'm going to extrude straight down from that curve. So surface, extrude straight. I don't want both sides, so I'll click that off. And I'm going to just pull straight down. I don't care how far down it goes. I just want it to go far enough. So if anything, make it overlong. Click. Alright. I can now delete that curve. I don't need it. Turn off my stone. And I'm going to use that extrusion to trim off the bottom of the seat. I'm going to join the extrusion and the seat together. And the last thing I'm going to do is I am going to extrude the rim of the seat straight up. I want it to be taller than the top of my stone, and once again I'll be generous. I will join this portion to the bottom portion of the cutter, hit enter, and then I will cap. So solid, cap planar holes. This will close up the flat areas, making a completed cutter. This cutter is now fine as it is. A habit that I have is I like my cutters to be a little bigger than the stone, just a little bit. So I'll show you what I do. You could just use this as is for your own work, but I like to come in and do a 2D scale, which is right-clicking on the scale button. Once again, origin point, 0, enter. First click, how big is it now? Click anywhere. Second one, I'm just going to pull this out until the girdle of my stone disappears. That's all I care about. I don't care how far out it goes. I don't want it to go much beyond the edge. Just until the girdle disappears. So that I know that my whole stone is now captured inside of this cutter. So that's my cutter. This is my stone. The next thing I want to have, we're creating a kit. For each stone we're going to put on the surface, we want to have a kit. We want to have the stone, we want to have a cutter, and we want to have a bumper, a guide. I'm going to create the bumper now. I'm going to use that girdle line that I have on my stone. Okay? And the distance I want between my stones at a 1.3 stone, I want 0.12 millimeters. So I'm going to offset this curve 0.12 millimeters. It'll look like that. What this is a way of me determining when my stones are the right distance apart. For example, if I have two stones here and I'm moving one over, putting it next to it. If I put that bumper line so it touches the girdle of the stone next to it, I will have laid out my stones very closely to exactly 0.12 millimeters apart. So that's what that bumper is for, is to tell you how close you're going to get to the next stone. Okay? Curves are hard to see in three-dimensional space. They're annoying. So we're going to give this just a little bit of thickness by making a pipe. I'm going to make that pipe 0.05 in diameter. So make it diameter 0.05. Okay? Now the thing to remember is that actually, I'm going to make it smaller than that. The smaller you can make it, the better. Make it 0.03. That's better. Okay? Remember that if you want exactly 0.12, that you want to kind of cut halfway into this bumper rim, that's just something to keep in your head. Practically it makes no difference. 0.12 millimeters is so small that in real life you'd have a hard time seeing it. Parsing it down to 0.03 millimeters on either side is craziness. But it is a principle to keep in mind. So we have our bumper, we have our stone, we have our cutter. This is our kit. Okay? So I'm going to group these. Actually, before I group it, I don't really want this curve anymore. I'll hide it in case I want it in the future. I'm going to keep the point in the middle because that will be useful later. But I'm going to change it to a different color. I'm going to change it to the same color as the bumpers so those points will be easy to throw away later. By hitting hide, Control H, it hides it on a hidden layer. Rhino has a built-in hidden layer. By holding Control Shift H, I can expose that layer and click on anything that's on that layer and it will come back. It's a very fast way to take geometry out of your way when you're working. The thing to be aware of when you hide is that if the layer your thing is hidden on is turned off, you won't see it. So for example, we happen to know that that curve is on the white layer. I'll hide it again. If the stone layer is turned off and I hit Control Shift H, it'll show you right here, all hidden objects are on layers that are off or locked. So it does tell you if you read the command line. But it can be confusing because you're going, wait a minute, I know I hid that. Where's that? I hit unhide, it threw it away. Oh no, it didn't throw it away. If you turn that layer back on and go Control, it's right there. Okay? Very, very useful thing to have. Okay, so I have my group, my kit. Next thing I need to do is to set up my dome. I'm going to lay these out on a dome. I'm doing this the easiest way possible, and that is to make a dome that's bigger than I need it, and then I'll cut away whatever's left because I'm lazy. Fastest way to make a dome is to create a sphere. I never use the Solid Tools tab. Oh, here we go. Thank you. Center radius 0. I'm just going to pull it out. That's fine. I'm going to move it down. I'll activate my front seaplane so I can see kind of what dome I'm making. Where I put it in 3D space isn't going to matter a lot, but that's good. I'm going to make it much, I want it to be fairly low, so I'm going to use a cutting plane. Actually, there's another command I can show you called wire cut. And you can draw a line, hold Shift key down, and when you're done, you can hit Enter to cut through the object. And then Rhino wants you to pick which side you want to throw away. We want the other, so we will hit invert equals yes, and then Enter. And that throws away the bottom half of that.
Why would you choose wire cut rather than a different action for this?
Well, I would normally use a cutting plane, but cutting plane requires an extra command. If you're fluent using wire cut, it can be very quick for slicing. It's like wire cutting a block of clay. That's basically what it's meant to do. So it's another way of doing the same thing. Basically just to show you another way of doing it. Okay. Now I'm going to scale this to make it as big as I think I'm going to want it, or bigger than I think I'm going to want it. But before I do that, I have to backtrack a little. I made a mistake. I am sorry. Those of you watching or listening. See this? This is a seam. I don't want the seam to go down the side of my dome. I want the seam to be non-existent. To get rid of that seam, I have to rotate this sphere. So I want to rotate it using my front seaplane. Transform, rotate, center, snap, so I can grab the middle of my sphere. Hold Shift key straight up, hold Shift key to the side, and now that seam is on the bottom. And that's where I want it, because when I'm through trimming this, I don't want to have to deal with a seam in anything. In Rhino, if you can get rid of a seam, get rid of a seam. I'm also going to rebuild this surface so that it has a friendlier point count. If I turn on the points for this, it's a locked sphere, so it's going to have the fewest points possible. And that means you can't modify this at all. If you grab any one of these points and pull on it, you'll get a kink. So to make a sphere that you can actually modify, should you want to do that, you want to rebuild that. And I will rebuild it 10-10 usually works. 10 points by 10 points by 3 as far as the third degree. Once I do that, I have a surface that I could actually play with if I wanted to in the future. If I turn on the points now, I have a solution that I can work with if I want to control point edit. I don't think I'll be control point editing, but I always try and leave myself the option of control point editing. As you can see now, I can pull and play with it, and I don't have any kinks or issues. And now I will go back to using my wire cut. And that's a much better looking piece of surface. Now, the other thing about a wire cut is it leaves you a solid, which is also nice. We don't really need it for this case, but it's nice if you want to have that. I'm going to scale this now into a dome that I want. It's just as having a good time with it. I'm not really meeting any specification. I'm going to 2D scale to start, because I don't really need a high dome for what I'm doing. That's about the height of the dome I would like, the degree of dome I'm looking for. Now I'm going to make the whole thing a little bigger. so I have room to lay out these stones without thinking. That is plenty big for what I'm going to try and do. I'm going to pop off the bottom, extract surface. I'm going to offset this surface to give me a thickness, like a real piece of jewelry. The thickness I'm going to give myself is 1.2 millimeters. That's important to remember if you're working in silver or gold and you're going to set pave. You want a thickness of 1.2. Okay, that's standard. Now, if a client tells you they want it 1 millimeter, that's fine. But you should instinctively always go for 1.2. Surface, offset surface. Now, it's important to notice the direction of the arrows when you do an offset surface command, because the dimension you put in, the number you type in, is going to be either positive or negative depending on whether you want the surface to offset the direction of the arrows or away from the arrows. We want it to go away. So I'm going to type in minus 1.2. Hit enter. And Rhino wants you to hit enter twice in Rhino 5. I don't know why, but it does. And there we go. The last thing to make this a solid piece of metal is a loft. Surface, loft command. Select curves to loft. I'm going to grab the edge of both of these surfaces, just like that. And when I hit enter, I'll make sure that my arrows line up, which they do. Hit enter, accept the defaults, okay. And that's it. Last thing I need to do is to join it together. I now have a solid, and this is going to be my piece of metal. Okay? 1.2 millimeters thick, ready to go. What I want to do now is lay out my stones on the surface of this piece of metal. You can draw on this sheet of metal if you want. You can lay it out any way you want. I'm going to do it by eye. A couple of ways. I'll show you a couple of ways to do it. But I do need to know where the middle of this sheet of metal is. That I have to know. So to get that, I'm going to draw a point at 0, 0. So it's asking location of point. I'll just type in 0, enter. There it is. And I'm going to project this point with using project curves command. I'm going to select this whole piece. Under delete input equals no, I'm going to change that to yes, just because I don't want an extra point floating around. That will throw away the original point. Enter. Now you'll see I have 2 points. It's because one went on the bottom and one went on the top. That's fine, I'll leave them both. Great, I'm ready to go. I am going to want to either move this piece or my stone kit out of the way so that I can see what I'm doing. I decided I'll move my stone kit. I'm going to use grid snap, and I'll move it in the y-axis. Okay. There is one thing we're missing, and that's prongs or beads. I can make those later, or I can make them now. There's no reason not to make them now. I'll go ahead and make them. Bead diameters. A couple of things you want to know about beads. Beads are always tapered. You want a slight taper to a bead. You want a rounded top to a bead. Okay? The size of these beads. Don't ever make a bead under 4/10 of a millimeter. It's unlikely to cast properly, and it'll be too small to set. Remember when you're doing pave that your stones are sharing beads. A 0.4 millimeter bead leaves nothing to share. Don't make your beads larger than 0.8 millimeters. 0.8 millimeter beads are just big and ugly. So between 0.4 and 0.8. I'm going to make it for this size stone 1.3. I can do a 0.6 millimeter bead. So I'm going to draw a circle, 0, 0, and the diameter is going to be 0.6. I'm going to extrude this. I want to have 0.7 of a millimeter penetrating into the metal, and then I want enough above the metal to capture my stone. I know that the crown on a 1.3 millimeter stone is going to be about 0.15, 0.2 at the most. So I want at least 0.2 above, 0.7 below. We're going to take 0.9. You don't have a lot of experience yet to be figuring these things out. Just know that you always want to have a good bury into the metal and enough above the stone to get it set. You want to have 0.2 of a millimeter above the table of your stone when you're finished. Okay, so I'm going to make this about 1.2, 1.5 millimeters. So I'm going to extrude it, but I'm not going to extrude it straight. I'm going to extrude it tapered. Extrude, curve, tapered. Oh, I have grid snap on. Okay. And I can see by looking at it what I want. You want barely a taper. What's showing on the screen now is too much. I'd like to tell you that there's a set draft angle you can use, but of course it's going to depend on the diameter of the prong. It will vary. All right. I'm going to set mine to be, let's see, right now it's at 5. Let's try 3. I like that. Draft angle of 3 is good. Okay? And the extrusion distance, I'm going to make it 1.4 for now. That's good. Now I want to put a ball on the end of this, a rounded top on this bead. So to get that, I'm going to extract the surface. When you extract a surface, make sure whether you're going to make a copy of it or not. I don't want a copy, so copy no is what I want. And you also want to know what layer you're going to send it to. This is going to send it to the current layer, which works for me. But I'm going to change the color so I can see that it is changed. I'm going to scale this 2D around its center because it's a circle. I just touched the edge. I'm going to scale it down really tiny, almost non-existent tiny. This is the fastest way to round a prong I know. And now I'm going to extract an isocurve. I want to visualize in my mind what the surface is going to look like connecting that curve with that little tiny circle I've left behind. And I think that's good. There. This will give me a nicely rounded top. If I made it less of a distance, it would be more cornered. If I made it a farther distance, it would be more softly rounded. You can do what you like, but for me, that's nice. Trim. I can delete that curve. And now I'm going to do a simple blend surface. Surface menu, blend surface. Click the edge of the cone. Click the edge of the little cap. Make sure my arrows line up. Hit enter. And you'll see that I have a reflection of what that's going to look like showing up here. I'm going to hit preview on the dialog box. That'll let me actually see it. That's pretty nice. I can change it. I can lock these two control bars together and slide them to get what I want. Hit OK. Join these together, and I have a bead.
How significant are these beads to the person who's going to be setting them?
Very. This is their setting device, so they're going to be very particular about getting what they want.
Even like the niceness of how round it is.
No, they don't really care. In fact, some setters prefer a hard corner because it's easier for them to get a hold of with their setting tool. Some like a very rounded top. I do something that's soft. That's not really a ball, but it's soft. Okay. Now, I just eyeballed all of this. I just made a nice looking bead. Now I want to make sure it's the right size and fit for my stone. That initial curve that I used to make it, I'm going to put that on a separate layer. I'm going to borrow my stone, or a copy of it. Now I hope it'll let me. It may not. Actually, I'll copy it out, paste it. Since it's a group, it could fight me. I don't want it to fight me. I'm just going to move it up here close to the bead. When you set, you want the stone to barely bite in to the bead. So I'm going to back that stone out until it's just kissing that curve. That's good. Could be a little less, could be a little more, but that's good. Now what I want is I want the top of the bead to be 2/10 of a millimeter off the table. Easiest way for me to get that, there are several ways I can get that. I'll do a cutting plane. Using the end points of that facet of the table. And that'll give me a big flat surface. I could have also drawn a circle and done a planar surface. I could have exploded this, taken this surface off. There are several ways I could do it. I chose that. I'm going to move this 2/10 of a millimeter up. That is where I want the top of my bead to hit. Roughly. Works for me. Now what you're going to notice is that it is no longer 6/10 of a millimeter at the girdle. Now that actually looks like a nicely proportioned bead for a stone that size, but it is too small. So I'm going to do a scale, regular scale. I want to grab the center of that top surface, just so I get right at the top of my prong. And then I'm going to scale the whole thing until it fills that area. And doing this by eye is just fine. Okay? Last thing I want to know is 0.7 millimeters below the girdle, because that's where I'm going to cut that prong off. So I'm going to move this 0.7 and use it to make a cutting plane. Center. Check the direction on that plane. It's good because I want to use it to boolean. You always want the direction of your cutter to face towards you, what you want to keep. And that's complete. That's the bead. Okay, so the last thing I want for this bead though is I do want to have a point at the table or at the girdle. I want it right here at 0, 0. Points are really important for if I want to change this later. I want to have that point there handy. So I'm going to put it there, and I'm going to group these together. Great, I am happy. I'm going to, actually I can move this, I can throw this away now. Do I want to move it right here? Do I want to leave it there? I'm going to move it right into the middle of where the stone is. Something tells me these got ungrouped. I'm going to regroup them together now. Even that little point. It's unfortunate that they became ungrouped. I wanted to keep them grouped at all times. There. So that's all of my bits and pieces. Here's my piece of metal. I'm ready to begin. That seemed like a lot of busy tedium, but once you're set up, I can lay out that entire surface quite quickly, if I want to. I will give myself a couple more guidelines on this surface. Cross section. Here to here. Here to here. Going to explode those because I only want the ones on top. Deselect them, delete the rest. That's just going to be handy if I want to set the stones up sliding along one of these rails. I'm ready to go. I'm going to turn off everything in my setting kit except my stone. Now I'll leave the bumper. Stone and bumper. Okay. The command we're going to be using is orient on surface. You want to record history. Transform. Orient. On surface. Select objects to orient. Select my stone. Now what you don't know is it's also selecting the cutter. When objects are grouped, it will select them whether the layer is visible or not. So when I orient this, I'll be orienting the cutters at the same time. Enter when done. Base point. Okay. Turning off grid snap. Base point is telling you where this is going to sit on the surface. We want this reference point right here. Reference point for scaling and rotation. That will be the point of our culet. Hello. That was not expected. That should not have died like that. Try it again. Record history. I'm going to pre-select. Orient on surface. Base point. That is very odd. One more time. Sorry, I don't use this command an awfully lot lately. Select objects to orient. Craziness is when you do the same thing over and over again and expect a different result. So, see what I'm doing wrong. One of the best things about Rhino is you can start a command and then you can hit F1. And that will bring up the help orienting. Now see, this is not allowing me to select the surface. And that is what's missing. That's what's missing. This should allow me to pick the surface, and it's not allowing me to do that. And I don't know why. So I didn't do anything wrong. Perhaps my challenge is that I am trying to orient a group. Let's try it with just the stone. I'm going to keep history off for a minute. is just dropping it again and again and again, and I don't understand why. I'll ungroup that several times just to make sure I'm not doing a group. Surface to orient on. Okay. Well, that doesn't really help me, people, because I can put this here. And that's not going to help me. Huh. I apologize to the person who was sitting next to me trying to have confidence in my divine modeling skills. This should work without a problem. Okay, I'm going to try not doing the stone. Do this instead. Orient on surface. Very odd. Very, very, very odd. I do this all the time and I never have a problem. This command works very, very smoothly. Like clockwork. It's not asking me even which surface to orient to. Okay, I'm going to try looking at the help again, but I already did that and it read perfectly fine. Yes, that may be what I do first. Here we go. Alright, well that didn't work. Okay, apparently my Adobe Flash has expired. Gotta hate that. I really hate that about Adobe Flash. So they'll actually stop you from using their product unless you've updated it. Never check for updates. Done. Okay. Yes. Exactly what I would have expected. Okay. This is exactly what I expected. Okay. So, going to follow the advice I was given. I'm going to save this. Going to open it back up. And try again. Orient on surface. just kills the command. Okay, let's try a different seaplane. It seems like a strange thing, but because I picked 2 points that were not on the top seaplane, that was it. To make sure that we're clear on what just happened, the pick points I made were not, when I was starting on the top seaplane, I was picking here and I was picking directly below it. The nature of this command, it uses seaplane information, which is typical of many transform commands. And since this point was right directly below it on the top seaplane, it didn't see what I was picking.
So it's the one right seaplane.
Yes. It would even have accepted front seaplane. It just needs a seaplane where it can see both pick points that I was doing. Mysterious. Yeah, I could set it to front seaplane and do the same thing. Yeah, it'll let me pick the surface. You just have to make sure that whatever seaplane you're in, those 2 pick points could be projected onto the seaplane. You ever notice how when you do a rotate command, it doesn't matter where you are in 3D space, it's technically projecting your pick points onto a seaplane. It's doing the same thing here. It's not telling you it's projecting, but it is. And if it's in a seaplane it can't project, it's not going to function. So, back on track. Now we'll record history. Orient on surface. Base point, center of the stone. Reference point, bottom of the stone. Surface to orient on. Okay? Now, it's giving you a choice as to how you can do this. You can put a scale. Uniform means it'll keep its current scale, or it'll set the scale to what you type here. So if you type in 1.5, every piece you do will go at 1.5 scale. 1.0 uniform means keep the same size. Rotation, you can either type in an angle that you want it to rotate each thing you put on the surface, or you can set it at 0 so it doesn't rotate it at all. Or you can click prompt, and that will allow you to click as you put it on the surface to set the orientation that you want. And the last thing is rigid. If you click rigid, when this thing is like when you use flow along a surface, if you set rigid, this diamond will stay a perfect diamond in position. If you uncheck rigid, it'll actually bend the diamond to fit the surface. So if you're using this to do if you're doing this to write your name on the surface, you would want to uncheck rigid so that the blocks of your name would warp to fit the surface, like a shrink wrap bag. But in the case of diamonds, we don't want any bending going on. So we will keep rigid. Okay? So, we'll hit OK. Now the next thing that's really important is to hit copy. If you don't hit copy, when you place this onto the surface, this will go away, and you want to hang on to that. So we're going to hit point, and you'll see what we're having. We're having an issue. Okay? And that's because and I will stop now so we can see what we've done. Because the orientation of the seaplane was the way it was, and this is the way it is, it's trying to set it according to the right seaplane. We want it in the top seaplane, which is very, very annoying. Okay? When this happens, we have 2 choices. We can set the ability to rotate on the fly, which is nice to be able to do. We can change the orientation of this stone so that we can access it from the top seaplane, which is what I'm going to do. So I'm just going to set this whole stone kit on its side like that so that I can use a top seaplane. But that doesn't make sense. Wait a minute. Those of you who are taking notes, pause. I've done this roughly 1,000 times. I've never had to do what I'm about to do before. So the fact that the seaplane wanted to be changed makes sense to me. The fact that it is not orienting it perpendicular to the surface, normal to the surface, does not make sense to me. I'm going to explode this so that it can't be taking the information off of the whole object. I'm also going to make sure that the direction on this surface is what I expect it to be. It is. Alright, going back. Orient on surface. Point. End. Surface to orient on. Right here. Okay. It's doing the same thing. And that does not make sense. So those of you who think I find this easy, surface to orient to. That surface. Scale. Okay. If I have to, I will type in 90 degrees. I'm going to try it one more time without. Alright. 90 degrees it is. You would not want to do this in live orientation, each one separately, because what's happening is you want it to stay specifically perpendicular to the surface. So we're going to set it to a consistent rotation. Starts. Okay, that rotated it. Before it was this way, now it's this way. It's only allowing me to rotate in that direction. So, give me strength. Last thing I'm going to try before I take a break. Orient on surface. Point. I'll just hold Shift key. I'm going to change my seaplane to top in the middle of the command. It was not impressed. I thought for sure that would remedy the situation. Okay. I'm feeling silly. I'm keeping it in top seaplane. Point. Instead of going to the bottom of the stone, I'm just going to pull out to the side, hold Shift key. It'll achieve the same effect. It'll keep the top of the stone flat. Surface to orient on. 0, please. Copy, yes. Point. Okay? For some reason it didn't follow the copy on me. It is fighting me today. Record history. Orient on surface. Point. Okay. Copy equals yes. There. Now I can keep laying these down. I'm going to hit near. I'm going to pull straight out. Okay? Polar array. And there are your stones. Okay? Now, you had mentioned that you wanted them to go circular. The stone sizes don't work for that. There's not enough room, so you're getting a square layout. Okay? What you'll notice now is I can turn off the bumpers. I can turn off the stones.
What stone size would get it to be circular?
You would have to experiment. I can do a union difference. Well, that's not going to work because I didn't join these back together. It's got to be a solid for a Boolean to work. I fully expect it to give me trouble because everything else today has. It's going to make me do them one at a time. Okay, where do the diamonds? Oh, shoot. Hang on a minute. Really important before I do this step that I ungroup, because otherwise it cuts the diamonds out too. There we go. Yes, that worked better. Which is why the Boolean failed the last time. It was trying to Boolean all the diamonds. now we do this. Now we do the prongs, which with this one is going to be the most difficult, because you see these big metallic holes. You don't want those in stone layout. They are not user friendly. You don't want to have them there. Okay, so they present a problem for us. Hide. Same idea exactly. Orient on surface. At least we figured out how to do it properly. Point, drag to one side. And now we can put these pretty much anywhere we want to, which gets to be a little bit scary. I'm going to pick this surface right here. Rotation, that's all fine. Rigid, that's fine. I do want copy. Huh?
Changed it to copy now.
Oh, thank you. Also, I need to back out because I definitely am going to need history, and I forgot to record history. The stone, I didn't end up needing it, but this one I will for sure. So what I've got to do is I've got to position this visually right in the middle of these stones. Fortunately, it's a symmetrical layout. So I'll only have to do this a few times. I'm going to let this bite in a little bit more here. I'm going to do another one of these over here. And no, I won't. No point. Okay. So you can see that it worked everywhere but here, right? Now I can change that by coming over to this piece here and doing a 2D scale. And it will update. But unfortunately, it updated all of them, right? So what I have to do in this case is I have to have multiple copies of this. One of these, in fact, I'm going to do another one because there's more than one way to do this layout. I'm going to make 3 of these little guys. Record history, orient on surface, surface to orient on. Okay, copy equals yes. I'll come in and put this guy just like I did before, as close to the middle of these guys as I can. Done. I'm going to take this guy. And set him up. The best that I can. I'm going to take this guy. going to put him over here. But instead of putting him in the middle, I'm going to let him bite quite a bit into this stone. Actually, let him bite quite a bit into these two stones. And I'm going to let him bite quite a bit into these two stones. I know that's not enough for what I'm going to need to do, but it's good to show you the point, the principle. So now I can change this guy. Scale 2D, where are you? There we go. Until he gets big enough to do what I want him to do. It's important that I scale him 2D so he doesn't get taller. Because if he gets taller, he's going to be farther above the table. And that works fine. Now these guys are going to do the opposite. Since they're both pulled off the same stone, the same prong, I can scale them down. At the same time. Now, I was pretty sure that was not going to work out great, and it didn't. But now I can at least tell that's about the right size. Since I know that's about the right size, I can just come in and do orient on surface again. See that distance between the prongs? Do you know how big that has to be? Bare minimum it can be for rapid prototyping is 0.07 millimeters. If it's closer than 0.07, the printer will fuse them into one bead.
That's going to fuse them for sure.
This space right here.
Yeah, right.
Yeah.
Is that okay?
Yeah, this is probably not okay. The goal would be 0.2. You like to keep the prongs 0.2 of a millimeter apart. Okay? 0.7 is the bottom, 0.2 is the ideal, 0.07. Now how can I find out? Easy. It's easy to find out. The way you find out, Miss Sarah, is you extract an isocurve. And I'll do it right down by the surface. I'm going to set a C-plane to that. You won't see any change, but I did. The reason I set a C-plane is because I'm going to offset it. And remember, offset curves always is C-plane based, right? So now that the C-plane's been set to that, I can offset it through point until it runs into the other prong. That's pretty good. I'll hit repeat, enter, and check. Those prongs are 0.02, 3 millimeters apart. That is fusion for sure. Okay, but that's how you would check it.
Yeah. So we'll do your first method.
Yes, the first method would be the way to go.
But we have to make sure that's not too big.
Yes, and the way you can find out how big it is the same idea. Well, first off, it's visual. I mean, it can be as big as it wants. You're going to be taking 4 stones out of this, and with shrinkage, they're all going to bite into that more than they're biting into it now. Okay, but you can take that and go analyze diameter. It's 0.78. That's okay. See, this is the deceiving thing. These are little tiny stones. So that bead looking big and fat is an optical illusion. You know how big 0.78 is. I mean, that's very small. And look how fat it looks there. Yeah. Okay, we've got that. So the last thing we're going to do is array. Array polar. And there you go. Okay. Now, if I'm a setter and I'm looking at this, I'm going to say those beads are awful low for me to set with. And I'm going to say, well, they're 0.2 of a millimeter higher than this. You idiot. I know what I'm doing. I would never screw that up. But the truth is since they're in between stones and they're curving, they're not quite that high. So to make my setter friend happy, I will come back into these two, right C-plane, and I'll move them up a little. Okay? Now, unfortunately, because Kimmer was a doofus, I didn't attach history to my polar array. I know you're too smart to make that mistake. Okay. So now, watch the magic. Whatever I do to these prongs here, so I can bump those up to where they look better, and that looks better to me. My setter friends like them. Even Stuller doesn't point to, because Stuller is this is what they do. It'll work. It's funny, when I gave my ring to the blue stone ring, I gave that to Mark to set. He said those beads are too small. It won't work. I said yes, it will. And when he came back, he said, like a glove. He said he just. I said, I know, because I do this for people who are chimpanzees. You know, guys at Stuller, it's not nice to call them chimpanzees, but they do the same thing all day long. They are not master craftsmen. They don't want to have to clean off any metal. If you put it at 0.2 of a millimeter up, by the time they push those down to hold the stones, there's no dressing to be done. It's finished. But in New York, you show setters 0.2 of a millimeter above the table, they're going, that gives me no metal. That gives me no metal. So you say, okay, you got metal. Now, you were asking how you could make this actually work going in a circle. You could, since the history is attached, you could scale the stone and have them all scale at once, and then eyeball it till you thought it was going to be good, and then do it again. Because as you eyeball it, as you scale them, the space between them is going to spread out, and you don't want that. But you can check by eye as you do it and see when you think, oh, that'll probably work. Okay. The last step with this, last two steps, would be to Boolean union. And it'll yell at you for breaking history. Okay? And then you want to cut this. And a square would be the logical shape to cut this in. But we can do it in a circle if you'd like. Circle or square? Okay. So you want to do square from center, rectangle center corner. I'm just going to hit 0. And I'm going to type in two numbers. I don't care what they are. 5, 5. All that matters to me is they're the same number. That guarantees me a square. Ironically, that's not a bad square for this. But it could have been too big, too small. I'm just going to scale it now to get it exactly what I want it to be. here's a good question, since we're talking. I am going to project this onto the surface. To do that, I have to extract the surface. I'm going to project with history. Oh, sorry, my bad. Record history, project, and I want it to keep a copy. So do not delete input, please. Okay, there we go. Now Miss Sarah, since history is attached, I'm going to scale this right up to the edge of my beads. There we go. Do you know how much metal you have to leave on the outside of your beads on a piece? 0.2 of a millimeter. So now I can take this base curve that I have, offset it 0.2 of a millimeter, and I will actually project that one onto my surface. And that's what I'll use to cut it. Isn't that nice? Okay. Actually didn't want to throw away the curve that I cut with. Oh, apparently I didn't. Apparently that curve's still there. Good. We're going to do an extrude normal. Make it plenty thick. Enter. Bring back our original plate. I will use that to trim away the bottom. Use the bottom to trim away the bottom of that extrusion. Join it all back together again. Get rid of my reference curves. Put back my stones. E-map it because we dig an E-mapped surface. There you go, Sarah. Yeah. And that is the way it is done. Okay? Control Shift S.